All right, now that we've introduced the idea of work, let's talk about the concept of energy. There are three kinds of energy. We have potential energy, which gets the symbol U. We have kinetic energy that gets the symbol K, and thermal energy that gets the symbol Q. Now you might be wondering why U. K is pretty obvious, and why Q? And basically we're running out of letters. So, okay, sorry about that, but these are the letters we're going to use. So I've got these three boxes for three different kinds of energy. And then I've also indicated work with these double-sided arrows. And so work is what changes one kind of energy into another kind of energy. And work also transfers energy from one place to another place. Okay, now let's look at the three kinds of energy. So potential energy, the potential energy of an object depends on where the object is. For example, if I've got something massive and it's up high, it'll have more potential energy than if it's down low. Kinetic energy, the kinetic energy of an object depends on how fast it's moving. So if I have a rock that is just sitting there, it has no kinetic energy. But if I make it go fast, then it has a kinetic energy. And then thermal energy depends on how hot an object is. So if the rock is hot, then it has more thermal energy. Okay. Now, the process of work, transferring energy between potential energy and kinetic energy, the work that happens to do that, it involves forces, pushing and pulling. The process of turning kinetic energy into thermal energy, it's work again, but it's work against friction. So now when you rub your hands together, right, your hands get warm, so you've done work, you've created thermal energy, and once you've done that, right, the thermal energy in your hands, there's no way to get it back into you. Back into your muscles, back into your food calories that you used up to create it. So when I made the diagram up here, I made this a one-way arrow. So it's really a one-way street, except for there is a way around this, and you might guess what it is. It has to do with an amazing invention, the steam engine. So the steam engine converts heat. You burn something to boil water, and the boiling water, the steam, pushes a piston, and that makes a steam engine go. And so you get kinetic energy back. Now, of course, now there have been other kinds of engines invented. There's the gasoline engine, diesel engines. There's something called the Peltier effect that turns heat into electricity, and so on. All right. Now, the last thing I want to do in this short video is kind of lay out the family tree for energy. So up at the top of this tree, we've got the granddaddy or grandmother, E for energy. And by the way, that's going to be the symbol. E is for energy. And this breaks down to the three categories: U, which is potential energy, K, which is kinetic energy, and Q, which is thermal energy. Now notice that I put a formula here. This happens to be the formula for calculating kinetic energy. This happens to be the formula for calculating thermal energy. All right. Now potential energy kind of subdivides into a lot of different forms. We have gravitational potential energy, and then the formulas that go with that. We have chemical potential energy. And okay, chemistry gets kind of complicated. You want to look up enthalpy and Gibbs free energy and so on. We have electrical potential energy. And here are the formulas for calculating that. And we have nuclear potential energy, and there's Einstein's famous E equals mc squared formula. Now here I made a little note to myself. I also forgot electromagnetic energy. What happened was one of my students pointed this out, and so, okay, I kind of messed up. I should have included that. Now, all these different kinds of energy have the same units, the units of joule. And so remember, the unit of work is the joule. And so work moves joules of energy from one place to another place. Okay, so I think, yeah, that's going to be it for this short video. Thank you very much.